Gone.
Hello, everyone. Is it working? Can you all hear me? Okay, so before we begin, I would like to apologize in advance. Yesterday, I strained my neck, so if you do see me turning around like an idiot during a presentation, that's the case. So, hopping on to presentation, honeypots. As majority of us already know, implementation of a honeypot is no trivial task. But today, former colleague and I will show you an easy way to implement an ADCS honeypot. I'm Josip. I currently work at InfigoIS, cybersecurity company, as a penetration tester and red teamer.
I'm Zdravko. I work at Span, detection engineering and research. I used to work with him, but obviously there was some skill issues, so we're no longer together.
Okay, so now let's jump right into it. So what is an ADCS? An ADCS is a Windows Server role for implementation, issuing and managing PKI certificates. Those certificates can then be used for encryption, signing, client authentication, computer authentication, etc. Also, it's important to notice that other than standard password authentication, you can use certificates via PKInit or PKI authentication to authenticate onto domain without using your password. So what do we get when we install ADCS? You get confidentiality implemented through encryption. You get integrity implemented through digital signatures. And lastly, you get authentication implemented by associating certificate keys with computer users or other devices. So ADCS does have a few components, and I would like to point out a few that are actually most important. First is certificate authority, used for managing and issuing certificates. Certificate template that actually gives the attributes for your certificates, like the name, PKI extension, EKUs, or just a template name, etc. Certificate enrollment web service and certificate enrollment policy web service are used in conjunction because in order for users to enroll or review certificates via HTTPS protocol, you would use certificate enrollment web service. How do we get the attributes and policies of those certificates is issued by certificate enrollment policy. Certification authority web enrollment is a GUI-based, basically a browser that allows the users to enroll certificates via browser. And lastly, network device enrollment service is used for offline devices such as router or switches to enroll certificates from ADCS. So can ADCS be vulnerable? Of course it can. SpecterOps in 2022 did a research, actually anyone who didn't read it, I recommend it. He did a research on few of techniques that can be used if ADCS is indeed implemented in domain. Then we had 8 different escalation techniques that lets us get to domain admin rights. 5 theft techniques that are, I personally never heard anyone talking about these, and I actually like them very much during internal network penetration tests, are used to steal certificates from systems. 3 persist techniques for local computer persistence, and 3 domain persist techniques. As of today, those escalation techniques more than doubled. We now have 70 of them. And most of these techniques are actually based on poorly configured certificate templates. So you're saying we can escalate, right? Basically, yes. Most of S techniques will give us the rights to get domain admin immediately. I'm saying mostly, 99%. And I would like to point out these few because these are important to our presentation today, from 1 to 4, 9, and 15. So in order for me not to repeat myself, most of these certificates, escalation techniques I already mentioned, actually require these 4 attributes to be implemented. And basically that is enterprise CA and allows low-privileged users to enroll enrollment rights. Manager approval is disabled, no authorized signatures are required, and enrollment rights to low-privileged user as per template. Other than that, ESC-1 actually requires for user to specify subject alternative name in certificate signing request, and it needs client authentication or smart card logon EKU to be exploited. ESC-2, on the other hand, needs no EKU or any purpose EKU. ESC-3 is the most, let's say, has the most prerequisite to abuse. You need a minimum of 2 templates. first needs to have certificate request agent EKU. Second template actually differs. You either need a version 1 template or greater than 2, but the greater than 2 templates need to have application policy issuance requirements for certificate request agents EKU. Also, it needs client authentication or smart card logon. Enrollment agents restrictions are not implemented on certificate authority. And lastly, request agents signatures are required, so the minimum of 1. We have ESC-4 that is by far the least, that has the least requirements to abuse, so it's literally just over permissive ACLs over 1 template. ESC-9 needs to have this flag set up, CT flag no security extension. This is actually based on a certificate mapping that is set up on the domain controller. You could actually speak literally about that theme, but I'm not going to deep dive into that. And client authentication, smart card logon EKU, just as some of other before. Lastly, ESC-15 needs to have a version 1, and certificate template allows users to specify subject alternative name in the certificate signing request.
So as Josip just mentioned, we have a bunch of ESCs that we can exploit. The thing that we should be generally interested in is how do we detect those attacks, right? So first of all, we need logs. We always need logs. It's a blue team curse. There are 3 of these which are important for us. So first, the 4662 event. This is a domain controller event. This triggers anytime that a specified monitored operation is performed or attempted to be performed on a domain object. Next up, we have the 4886 event, which triggers every time somebody tries to request a certificate. So not if it succeeds, just an attempt is enough. And finally, we have the 4898, which effectively says, hey, your CA loaded a new template, or a template was modified and reloaded or something. So the Sigma rules for ADCS are kind of different than the usual detection rules. They're not reactive, they're proactive. So instead of looking for requests containing SANs, Sigma looks for any templates which were loaded, which either contain a SAN or contain a SAN and a potentially exploitable EKU, such as client authentication or smart card login. Now, these are good. These are great. We have logs, we have Sigmas, we have everything we need with the entire plumbing. The problem is that ADCS logs are not ingested that often. Now, there are a plethora of reasons why this could be. Clients typically state performance reasons, which, correct me if I'm wrong, there's like 1 edge case that I'm aware of for performance reasons. Cost reduction, because there's a billion requests daily that you need to ingest into your SIM. Knowledge gaps, some people just may not be able to, or do not have the knowledge to enable logging, ingest that, keep the SIM rolling. And the worst part about all of this is that even if you do all the things correct, you ingest your logs, you monitor those logs, there are still 2 metrics that can severely hinder your ability to even respond to ESC attacks. So this would be the MTTD, or the mean time to detect, which means that if your SIM has a parsing delay or storage delay, or you have a cloud SIM, so it goes on a polling rate, it's not perpetual, you can get slowed down there. So this is typically a minute up to 5 to 10 minutes, depending on your SIM, on your config, and the mean time to respond, which is, okay, now I have a detection. From this moment on, our MTTR starts rolling. This can obviously depend on the SOC's response time, their internal procedures, the technical levels, and everything else. And if you're like me, you don't want an attacker anywhere near your network, let alone giving an attacker domain admin rights for half an hour. So there needs to be a better way. Now, we had several discussions regarding honeypots today. So let's see what even a honeypot is. How do we implement this? Well, first of all, a honeypot, at least what GPT said, it's a deliberately vulnerable decoy system designed to lure attackers away from real assets. Now, this is very nice, but there are a few other prerequisites for honeypots. First, they should never be touched by genuine activity, legitimate users. You can't use an existing file share as a honeypot. Don't. Secondly, honeypot, if set up correctly, they should be a tripwire. So if anybody touches those, that's 100% detection. That's insanely high fidelity. Typically, this is somewhere in the range of 95 to 99%. There's always that Nessus or Qualys or something that's pinging those honeypots, but you can set that up later. Next, we need a honeypot to be secure. You can't expand your attack surface by incorporating additional defensive mechanisms. And it needs to be either hard to distinguish or basically indistinguishable from the real thing, so an actual vulnerable system. If you'd like to play with these in your free time, you can use canary tokens. I'm not sponsored. They're just a cool technology that lets you basically craft your fake credit cards, fake DNS entries, URLs, whatever you'd like, and plan them as you go along with your life. Now, before we dove into the ADCS honeypot, we decided to look at some of the previous investigations people have done. And there are the 3 ones which we would like to highlight first. And the oldest one was done by Pavičić in, I believe, 2022, where they created an ESC-4 template, which, when modified, would trigger an alert in their monitoring solution. Now, it's very important to keep this in mind. Pavičić did this honeypot with the idea that you have their monitoring solution on the endpoint, right? Why is this important? Well, if you have an ESC-1, which typically the flow goes ESC-4, we convert it to ESC-1, right? Because we have weak ACLs. What Pavičić wanted to explicitly state is template modifications which are logged can be acted upon if you have the solution. If you don't, you suffer from the same consequences we mentioned before. So the MTTD, MTTR delays. The good thing about this is it does not require the deployment of a new CA, so you can use your existing infrastructure. But the bad thing is that the vulnerable template can be deployed on other CAs. Now, this might not seem that terrible, but you may not have logging set up on those CAs. You might not have agent collectors set up. There might be some firewall issues. There's a bunch of things that can go wrong, right? And this is not necessarily a bad thing, but it's like a bonus. It only accounts for ESC-4 attacks. The better version is a Reception published by SR Labs, who create an ESC-1 template instead of an ESC-4, and they did a slightly better job. So they created a new CA. On that CA, they deployed a policy module via theme-icerts. Now, a policy module is effectively an XML file implemented through a DLL, which tells you, hey, if your certificate request does not match this specific requirements, it cannot be issued, right? However, the bad part is that you still need a new CA, and once again, the template is still available on other CAs. We do not want that ideally. There's 2 pathways we can take. Either don't deploy the CA, or don't deploy the template on all CAs, or if you can deploy it, make sure it's not actually vulnerable, which is what we're going to touch. And finally, theme-icerts, which is not really a honeypot per se, but can be used as a honeypot. And the great thing about theme-icerts, which, as I mentioned, is a policy module, it can be used to enhance your existing detection. Why? Because theme-icerts comes with its own proprietary set of logs, which can tell you exactly, hey, somebody requested this template with this attribute, which does not match the spec. Okay, so the good thing about theme-icerts is it's generally a good policy module to deploy on your PKI servers, but if you have a bunch of templates, a bunch of requests, a bunch of people, or the other extreme where you have like 2 people in your IT staff, it can be cumbersome to maintain and deploy.
Okay, now on to the fun part. So how this idea came to mind? The correct answer would be under the shower, right? Just kidding. During one of our mutual red team exercises, me and my colleague, actually this is not the exact example, of course, we came up on one of the templates that, as per certify, seemed to be vulnerable to ESC-15, right? But even as certify states, I don't know if you can see it, it is only applicable if the environment has not been patched. There is also one more case that we can fix this, but I was thinking to myself, this could be a very easy way to implement a honeypot that's stupid enough, because during a red team engagement, let's say, or maybe some APT is desperate and he needs those privilege escalations, so maybe he will request it, right? So now let's check out how this works. So basically, ESC-15 implements additional application policy that was not there, client authentication, and then user can simply sign to LDAP and get those administrator rights from the low-privileged user. Like I said before, there is additional way to fix this without implementing a patch, And that is simply set up a registry key on the CA that will deny all application policy used on certificate templates. So what would happen if we implement this? No more signing to LDAP on domain controller. This is cool and all, but during our other research, we came to more fun solution. This is very simple and, to be honest, not so fun. So now let's go to the fun part. I will show you the two templates, both, like certify says, vulnerable to ESC1, right? So I don't know how many internal network penetration testers or red teamers. Can anyone raise hands? Who is doing internal network penetration testing? Okay, so both of these, think in your mind, like both of these are vulnerable, right? You cannot actually see any difference. So let's try to abuse both of them. We should get those domain admin rights on the both. First one, ESC1 Trust Me Bro, gets our administrator certificate, very nice, but the second one fails. I purposely hidden the error part because that would spoil the fun, but this is, I mean, during the internal network penetration test, this would be, I don't care, but during a red team engagement, this would be very depressing because we thought this one was vulnerable. We thought we were going to get domain admin rights before lunch, as they say, but that's not the case. So what do? We can check with another tool. We have certify.net implementation of certify or vice versa. I don't know who did the first. So we have ESC1 Trust Me Bro. It says literally template has client authentication EKU and allows enrollee to supply the subject, right? Vulnerable. The one we saw gave us administrator certificate, right? So let's see the difference. Pay close attention to this. One more time. Yeah, literally, so stupid, right? Nothing but the name changes, and I didn't cheat. This is legit output. No, we have no answer to this, let's say, bug. Let's try another tool. This is Locksmith, a PowerShell tool that checks also for vulnerable templates. Same stuff, right? Same stuff. Both are critical. Both domain users can provide subject alternative name in CSR. So then this doesn't give any additional answers either. And lastly, to do like a real OG, like a GigaChad, you do LDAP query, right? LDAP queries are the most, actually the best way to enumerate templates. The only issue is not many people can actually determine if this wasn't named ESC1, if it's even vulnerable, right? It's very hard to parse this thing. And also, via LDAP, we can actually see what's wrong with this template. You would see it eventually. It's very, very hard if you would compare a literally normal template, but it's very hard. Trust me on this. So what do? We don't know the issue right now. So what do? We say, it's not me issue, it's not tool issue, right? The tool is well known, it's client network issue. There must be something wrong with their CA. And what would happen, let's say we play literally a red team engagement. We already told our boss and our seniors, trust me, I have domain admin rights. We will patch this up real quick, and then you get that one fail. Luckily for us, we have ESC4 template, which has much less requirements in order to abuse it, unlike ESC1. We literally need just misconfigured ACLs. And as certify states, it's vulnerable, right? User has dangerous permission. If you check this out, we have write DUCL principles that lets domain users change the DUCL to write on a DUCL. Okay, but we are not stupid enough. We won't gonna request the certificate just yet. We're gonna first check via another tool, certify, that also tells us template has insecure delegated permissions. And if you see on on object control permissions, we have write property domain users, right? So users can write the property of a template. Another plus for us. Let's do another check. We have ESC4 that also says it's critical. Domain users have granted self-write property and generic read rights on this template. So now lastly, what I added specifically for ESC4, I added an enumeration via beacon object file, and we can also see ESC4 template, domain users with write property all rights. So we are good to go. We'll patch this up. It's done. Red team engagement is over, right? We can change the attributes in order to modify this template to be vulnerable. We are good, right? Then this happens. We get user low priv. I guarantee you he is inside domain users. It's very hard to remove a user from the main users group in Active Directory. Trust me on that. Doesn't have permission to update these attributes on ESC4. So we don't know what is happening. But we already told our boss, our seniors, we have domain admin rights. And I will simply just show you a simulation of what would happen during one of red team engagements. Your seniors would be like, where is domain admin? Right? Standing like monkeys. Your boss already knew you ain't getting those domain admin rights anytime soon, or maybe never. He would just send this, right? And the rest of your pen testing crew would simply say that that is skill issue. You, as a rational human being, have only one thing left to do, right? You gotta break that computer down. But that's just a joke. So now I will tell you how we did this actually by doing it manually. What are templates, attributes, and its ACAs, access control entities. First, let's check on that ESC1 template we showed earlier in the example. We can see this is an object. These are its users and security descriptors on this object. It's actually quite easy to understand this. Just using my cheat sheet, we can simply get the rights we need. No, just kidding. We're not going to do that. It's very hard, very tedious. Other tools are going to do it for us. This is a zoomed out example of all the ACEs on our ESC1 template object. So let me zoom in on this, and most of you can already guess what is wrong here. And the correct answer would be the first ACA, right? We have on our object, ESC1 template, we have AC, access denied object ACE. Okay, for why denied? We have denied for read property. Nice. What read property? That would say in object ACE type, the only, let's say, non-human readable stuff here. And for who is this implied? Security identifier will tell us. Anyone who is administrating domain knows that that RID, the last 3 digits, is actually a relative identifier for domain users. So what can we conclude out of this? Domain users have read property denied on a certain object. So let's see what this GUID representation means. Simple Google will do, right? So MSPKI RI signature. So I already mentioned this correlates to those signatures required. Why would we hide an attribute from domain users? Why can't they read this attribute? It's literally dumb. The answer is quite simple. As certified, as certified, and many, many other tools do not even check ACAs on an object. Certify, if you can't read, if the template requires manager approval, authorized signature, it will default to 0. So no need for manager approval or signatures required, right? Because I can't read it. So this is where you get the idea, right? This is that point what we did in this honeypot. It's actually quite simple when you look at it. How to do it? CA is actually used for managing your templates, but CA won't be enough, right? Because templates on a CA don't have the entire ACA list. We have only these like 5. Full control, read, write, enroll, auto enroll. We can either allow or deny them. Where are the templates actually stored? They are stored on the domain controller, in domain configuration part, in the services, public key services. I did use a different template, but that's not the issue. We can see that if we click on advanced, on a security, we will get the list, entire list of attributes of one template. And it's very simple, just clicking deny on a read of one attribute, and then when building a template, we set either signatures required, manager approval, any of that, and template will no longer be vulnerable, but all of these tools will tell you it is. It's quite an easy way to set up a honeypot. And lastly, this is just a short list of ACAs we actually used in all of these previously mentioned vulnerable ESCs. So we can hide RI signature, enrollment flag, template schema version, and PKI certificate application policy, certificate name, or extended key usage.
Okay, so is this working? Yeah. Now that Josip has given you an overview of how this thing actually works, we are still missing the second part, which is actually detecting when somebody is tampering with our honeypots. So let's catch Winnie in the act, right? First, we need logs. Once again, I'm here to tell you we need logs. Let's enable the logs. We need 4886, which tells us, hey, somebody requested something. The way we do that is twofold. So first, we're going to go to our audit policy, typically on your DCs, and say, hey, enable auditing of certification services. Success events are enough for this. I like to enable failures in my lab as well, but that's besides the point. And the other part is we need to go to the actual CA and enable auditing of certificate issuance. Right. Now, let's go and request a template, and we get the 4886, which states, hey, this was the request ID, this was the requester, this was the template name, the subject alternate name, the application policy which was injected if there were any, and so on. In this case, and this was a honeypot template, we also get the 4888 event, which states effectively the same thing, except that there's a different message stating that DCA denied this request. Bless you. So those were non-ESC4 events. About ESC4, we'd have to take a slightly different approach. Why? Well, the first approach relies on the fact that somebody is going to come, they're going to request a finished template, which is vulnerable. ESC4 templates, by default, do not necessarily have to be vulnerable. The only requirement is they have a vulnerable ACE, which means someone can come in, modify the template, and then make it vulnerable. So we need to take a different route. The way we do this is using everyone's favorite SACLs. I know there's at least one person in the audience who loves SACLs. So what do we do with SACLs? We are going to enable directory service access logging for failure events. Once again, same principle applies. This is going to trigger 4662 events in our event viewer every time somebody tries to do something with a SACL monitored object. Now, what are we monitoring? The template. More specifically, we're monitoring for any failed writes from the main users, because as Josip mentioned, we are restricting the main users in this case, whenever they try to write any of these attributes. Now, you might notice this read permissions here. I'm not going to get into that. It's a long story. Okay, let's detect that. We trigger an ESC4 event using certify. We tell it to write the default configuration. The configuration update fails. And we get a 4662 failure, which states, hey, this user requested this template, and they tried to write the discretionary access control list. And that, my friends, is how you catch highly sophisticated APTs in your environment, exploiting highly sophisticated vulnerabilities such as ESC1. Now, that's cool and all, and you come to your SOC client, and you're like, look, I can explain all of this. And the client is fuming. They're like, you want ADCS logs? You know how much that's going to cost? You want SACLs? I don't have anybody to do SACLs. And then you come to an incident. Things usually look like this. Because if they had a SIM, they probably wouldn't have had an incident. It sort of correlates. So what about the people who don't have SIMs? Or, as the picture would say, no logs? Well, no problem. We can use offensive tradecraft for that, as we'll see. But first, let's see what problem we actually need to solve. So many organizations with fewer IT staff lack the resources, the knowledge, the time, or just the staff in the end to manage both of their users and reset passwords and fix laptops, reinstall those things, and then still take care of ADCS, right? Plus, that's a sort of niche thing. The good part for us is that this usually correlates with the amount of logs we generate. So the fewer people, the fewer logs, I would hope. Now, this will be important later on. This means we need a solution which is easy to implement. It's high fidelity. It's pretty black and white. Whenever this fires, that's an incident. There's no need for you to investigate any further. And it requires that an alert can be fired without a SIM. So Teams, Discord, Slack, Telegram, name your favorite communication channel, it has to be available. And finally, it's reliable enough for smaller orgs with, once again, no log aggregators, no SIMs, no nothing. We can use WMI. Now, what exactly? I mentioned WMI-enabled canaries, but first, what are canaries, and why do we call them canaries? I also mentioned canary tokens. Well, back in the day, coal miners used to bring canaries with them in the mines, and every time a canary got sick or a canary died, that would be a sign for the miners to get the hell out of there because there's some toxic gas leaking or something else. The same principle applies. So we can generate a webbug URL. This effectively triggers every time we visit that. The canary console is going to ask us, hey, give me some email, or even a webhook is available, and just tell me how you want me to remind you of this alert. Why did this fire? Once you do that, you get a nice little URL, and it also states, remember, it gets triggered every time somebody visits that. So what actually happens when we visit that, you get a nice image of a supposedly round globe of the Earth. I'm not going to get into that. You get an email, and you get an alert in your console. So that's part one. The other part regarding WMI is actually fairly simple. The thing with WMI event subscriptions and the offensive part of WMI is that an attacker can come and set up persistence in a way where they can say, hey, every time I fail a login with a specific username, I want you to fire off a payload. And that's how I regain access to the domain. We can use the same principle to our benefit. So instead of saying any logon fail, we can say whenever there's a certificate request with our template name, so a certificate request for our template, we can fire off a PowerShell script. The script does nothing except fetching the latest request event for our template and literally sending the event message to our console. So let's try that. We can use certify to enumerate the templates. We find an ESC1. All of the requirements are satisfied. We don't need manager approval. We have 0 authorized signatures. Of course, the request fails. But because we requested a template, there was that 4886, which fired. Our WMI came across that and fired off a script which pulled the data from this event and triggered an HTTP request. Now, we've gone through a lot. We've gone through SACLs, we've gone through manual setup, we've gone through what even is a honeypot, we've gone through all of the ESC types, we've gone through a bunch of things, which, if even slightly misconfigured, can end very badly for your domain. So if you forget to change the value of the RA signature, even if you apply the deny read, that's still a vulnerable template. So what Josip and I decided to do is, let's automate this. First, let's automate it so we can reduce the number of mistakes, but also let's automate this to give the people who don't have a lot of IT staff a fighting chance against script kiddies, at least, because let's hope that an APT is not attacking a 50-person company. So what did we do? We created a certi. So it's not certify, it's not certify, but it does lie to you quite effectively, we would say. It's an open source PowerShell module which creates or has the ability to create ESC 1 through 4, 9, and 15. We also could have done 13, but that was not very nice and easy to create. Plus, it's not really found in the wild anywhere. We also added the support for WMIs, or canaries for non-ESC4 templates, and we also create the failure SACL for the ESC4 template object. The script is available on the GitHub. It has an MIT license. You can do with that whatever you like. It's open source as it gets. The only prerequisites are effectively you have ADCS installed. How does the tool work? Well, this is just a help, so it's nothing too important, but it actually states you can create a certi template, you can remove a certi template, and these are basically all the types we support. So first, we want to create a new template. It's going to be an ESC1 template called B-Side Zagreb. We use canary tokens for this one. The script will modify the local GPO. So keep this in mind if you're deploying this to production. Make sure to change those settings on the DC as well. And it pops open the MMC console, prompting you to change the audit policy on your CA. Once that's done, or hopefully that's done, you get a prompt to enter your canary token URL, and we can move on with actually creating the certificate template. So first, we create the template, obviously, publish it to the CA, and then we ask the user if applicable. Some templates automatically choose their own property. If applicable, which property do you want to hide? We typically recommend RA signatures because it's less weird to see a template without RA signatures than it is to see a template with no enrollment flags whatsoever, but that's up to you. Once you select your value, we're going to say, okay, we're modifying that to a safe value. So now this template actually requires a request agent signature and cannot be issued without one, right? Once that's done, we hide the RA signature property or your property of choice with the safe value, and you get back some metadata about your template. Now, if we try to abuse that with certify, we enumerate the template. We can see it's, again, vulnerable. Or you can't see, but it's vulnerable to ESC1. If we were to try to request that via certify, we get an RPC error stating that, hey, you need a signature. It's required by the policy. And of course, 4886 fires in the background, sending the canary an alert. If you want to remove that, just run remove the template. It unpublishes it from the CA, it removes it from AD, and it goes ahead and checks if you had any WMI subscriptions, whether or not you would like to remove those as well, because they can be a pain to remove manually. Just keep in mind, this does remove existing non-certified templates from your AD, so make sure not to mistype anything, okay?
And thank you all for coming. We'll be taking donation for this tool. Just kidding.
Since we have time for questions, maybe think about it. I'm just curious one thing, maybe I missed it. So, Certify says that it cannot create a new certificate because it cannot read a field, right? Due to properties, right?
A bit different. It cannot read the property, but it's going to use RPC to communicate to the CA and tell, I want that template. But once the CA comes back and checks and says, hey, that template needs a signature or management approval, it's going to execute the function. It's going to either generate a template if management approval is required, but it's not going to give you the certificate until a manager approves it, or it's not even going to issue it if a request is.
Okay, that was my question, because if this certifies a Python script and it's probably in packet or something to connect with RPC, so is it just certify being dumb and not being able to send a request because he cannot read something, or
it's tools being dumb,
Yeah.
and mostly you do not want to use open source tools, especially during red team engagement, because the proper, like I said before, the OG way was to LDAP query a template.
Yeah.
Not many people do it actually, and not many people know how to do it. That's, I would say, skill issue.
Yeah. So how many of you have done any kind of red team engagement pen test and tested your templates? 1, 2. I know some are shy over there. Yeah, 3.
The other ones aren't pen testers, that's fine.
Yeah. Any questions?
Oh, God.
Yeah. Yeah. No.
Could you please stop the cameras?
So
Roll credits.
The access control list, the deny access control list is on domain users.
Yep. Access control list is specifically on a template we want to avoid being abused. So domain users can't read specific attribute on our honeypot template.
And if we remove ourselves from the domain users group,
That's a great question.
You needed. It is a good question.
Yeah.
We were actually evaluating that because
But you need the domain admin for that, to remove yourself.
Also because most of users, correct me if I'm not mistaken, they have domain users as their primary group, and you do need domain admin rights to remove that. Another thing we actually did get in mind, you could actually use machine account, right?
Yeah.
Yep. But we were thinking about it, not to do it. To do it, you can actually do it. It's literally just don't use domain users, use also machine account. But that would be quite tedious to manage. And also we were looking into perspective, like most of the red teams actually start from domain users. Yeah. And I don't think many people would think, why did I don't enumerate the templates with machine account? But this, like I say, it is another option, of course.
Mm-hmm. What would happen if we put authenticated users?
From what we tested, I'm assuming the CA would have an issue with reading those templates. So you could play, like we talked, you could play along with the ACL ordering or the ACE ordering, but that's a good pull request. Please submit that. Yes.
I will.
Yeah.
Yes.
Cool. I was wondering about one thing recently. So when I first heard about these issues years ago, it was like, well, okay, so everything in normal enterprise environments is, centralized, IT environments, IT department creates devices, machines, they enroll them, they provision the device certificates, they create users, they get the certificates. There is absolutely no need for a user to be able to do anything, basically. But then I heard last year, then Microsoft, in their own wisdom, is saying, okay, you're gonna have agents soon. You have more than one agent for yourself because you want personal agents to work with your credentials, not with some admin credentials. But you don't want full scope for every single agent to have a full scope of your credentials. So you want to have like 17 different agents and 17 different agent identities, some principal name, some SPN or something in that regard for each of them, scope to a smaller range, and you probe use certificates for it. So will that change, our setup where we will have to again grant some kind of broader access for end users, or will some application, do that for them, or what do you think? Will we have a new big problem with ADCS very soon?
Well,
because of all of that.
It is quite thoroughly researched. Maybe new exploits come every day. Like we've seen, almost doubled from the primary research SpecterOps did. So who knows? It's Microsoft.
Yeah, we like Microsoft. Yeah. Any more questions? Don't be shy.
I know somebody from the first row supposedly had a bunch of questions. They're staying silent, but okay.
In that case, catch them during the coffee break. Thank you very much, guys. We are back in 17 minutes. Dečki, evo ga.